Dear students, in continuation of last lecture in which we have discussed about the circuit, and in this circuit we are assuming this biasing, and with this biasing a particular AC signal is applied across it. So in biasing condition we calculated all current and voltages, DC current and voltages, and we found VB equal to 0.7 volt, IV 20 microampere, IC 2 milliampere, and VC 10 volt. These currents and voltages are due to only DC source. Now, if we apply AC source, means input, to this bias circuit, means we are going to apply AC source to this bias circuit. That means initially we are having VBE equal to 0.7 volt. This is particularly purely DC, and if we apply an AC source, that means this AC source will be shown by VBE, and suppose its value is 20 millivolt, as we have shown in previous lecture. We are considering this circuit and the applied voltage is 20 millivolt. We assume that this voltage is associated with VBE. Then total VBE, it will be indicated like this: lowercase, uppercase. It is indicating AC and it is indicating DC. That means this is combination of AC and DC, and so it will be 700 millivolt plus 20 millivolt. That will be 720 millivolt. Not fixed value, because this VBE is varying voltage actually, and it is varying to maximum voltage 20 millivolt and minimum voltage minus 20 millivolt. So now this VBE will vary with respect to, suppose it is VBE, this is value graph of VBE with respect to time. So value of VBE will vary with respect to level of 700 millivolt. 700 millivolt. It will be up to 720 and then 680. 720 millivolt and 680 millivolt. In respect of this, there will be variation in IB also, and we know there is a graph between VBE and IB, and this is non-linear graph, and in respect of this we can see when we apply AC signal, VBE is varying between 720, 680 to 720. In respect of this, IV will also be varied between these two values, and its center value will be 20 microampere, which we have calculated. 20 microampere. So value of IV will vary with respect to 20 microampere. Sometime it will be higher for 720 and it will be at lower level for 680. Meaning is that when we apply this varying AC signal across VBE, that means between base and emitter, in respect of this there will also be variation in IB. So this current IB will now be IB, and that will be equal to IB plus IB, and this will be IB plus minus 20 microampere because it is varying signal. Sorry, 2 microampere. We are assuming that variation in IB due to variation in VB is 2 microampere, and we have calculated initially that IB is 20 microampere. So variation in IB will be with respect to 20. So its maximum value will be 22 microampere and minimum value will be 18 microampere, and graph of IB can be like this. This is time, this is IB, this is the level of 20 microampere. So IB is increasing up to 22 microampere and it is decreased to 18 microampere. That means variation in IB is this amount, and we can say it del IB. So in respect of this current IC will be definitely beta IB. So beta will be multiplied by IC plus IB plus IB. If you are considering AC signal, if you are considering only AC signal, then IC will be beta IB, or we can say change in IC will be equal to beta multiplied by change in IB. Meaning is that the variation, if the change in IB is 2 microampere, so change in IC will be 100 times of variation in IB. So variation in IC will be around 0.2 milliampere. So when input current IB is varying in the range of 2 microampere, and in respect of this variation in IC is varying with respect of 2 milliampere. That means there is some amplification. This is 2 microampere and this is 0.2 milliampere. That means at input current is varying. Input current variation is 2 microampere and in output it is variation to 0.2 milliampere. That means output current is 100 times of input current. That means we can say that BJT is showing some amplification factor, and in that case amplification gain is around 100. Similarly, we can see in the case of VC also. In our calculation, we have calculated initially that is VC is 10 volt, and when we calculate VC for AC, we find out that change in VCE will be around 1 volt. That means at the output we will get around variation of 1 volt. So what was input? Input was VBE and its variation was around 20 millivolt. Variation in VBE was around 20 millivolt, and in respect of this variation in VCE we are finding is around 1 volt. That means At input we are providing 20 millivolt, and at output we are getting 1 volt, and this is gain. That means gain of this amplifier will be 1 volt, that is output, divided by 20 millivolt. So by using this example, we can see that BJT can be used as an amplifier, because at input we are applying 20 millivolt AC signal, and at output we are getting 1 volt AC signal. In that way we can say the gain of this amplifier will be 1 volt output divided by 20 millivolt. That means 1000 divided by 20, around 50 I think. So similarly, at input we are providing current of around 2 microampere IB, and at output we are getting around 0.2 milliampere, that is 100 times of input. So we can say this amplified circuit is providing amplification of 100 in current domain and amplification of 50 around in voltage domain. In next lecture we will discuss about the step to use in analysis of amplifier. Thank you.